Hey there, I'm Courtney Cox-Darquette, lead camera person on set. This camera here is one you're likely to see in any production studio you visit. The way this camera works is pretty simple. Light enters the camera through the lens, that light then hits the charge-coupled device, and then converts the light information into an image. Now inside of the body of this camera there are actually 3 CCD sensors. There are 3 because to be able to process and redistribute color information, it has to measure light at 3 separate wavelengths. That's one for each primary color, red, green, and blue. So in order to do this, a prism block is used to separate the image being captured into the reds, the greens, and the blues. Because of how the prism is assembled, each of the 3 colors gets its own charge-coupled device. That means the CCD is able to devote all of its pixels to that particular color channel.
An advantage to using CCD is the resolution. Even though a CCD sensor uses a lot of time and energy converting each pixel, it can hold a large amount across its surface. However, a downside to CCD is what's called the blooming or smearing effect. This happens when a light-gathering pixel exceeds its capacity to hold captured photons. That excess spills over into the adjacent pixels and can produce a spike of light in the image. There are other options when recording video. For instance, the cameras you use to record Snapchat videos on your cell phones uses a CMOS sensor. Though they record less resolution than a CCD, CMOS won't cause blooming or smearing. To get a better idea of what CMOS sensors are, meet Charles at the CMOS Institute.
Hello, I'm Charles Moss from the CMOS Institute, and today I'll be talking about CMOS sensors. Let's get started. CMOS, which stands for Complementary Metal Oxide Semiconductor, is the sensor that can be found in most cell phones, web cameras, and DSLRs. Let's look at how these sensors work. First, light enters through the lens and is directed to the CMOS sensor. A primary color filter sits on top of the sensor that divides the light into red, green, and blue. The sensor converts the light into an electric signal, which is then in turn converted into a digital signal. This signal then carries and imprints images on whichever storage device is being used. CMOS sensors generally work faster than CCD sensors and require less power to operate. They are also cheaper to manufacture and more compact, making them ideal to include into consumer products. Another advantage of the CMOS sensor is that because they capture each pixel individually, they don't have the same blooming and smearing problem that CCDs have. One of the main drawbacks of using CMOS sensors is what's called the rolling shutter effect. They scan images the same way we read books, moving from left to right, line by line. This creates problems when trying to capture fast-moving subjects or panning the camera while shooting, as it can create a distorted and inaccurate representation of what is being captured.